Okay, so this Excel sheet is, once again, it's on Moodle, so you can click on the Excel sheet on Moodle and you'll see this pop up. Okay, we're on the tab that says NPV on the bottom. Okay, so there's a few tabs. There's an NPV, IRR, NCCF, MIRR, PI, and a quiz tab. We're on the NPV tab to start out. Okay, so we were talking about why the NPV is important. We talked about that it's good decision-making criteria and it's helpful for financial managers to assist financial managers in making investment decisions, capital investment decisions particularly. So how do you actually use this NPV concept? Well, we talked about this formula already, but we didn't put it in practice. We laid out a bunch of details on this example where there's going to be a $165,000 investment in right now, and in year 1, 2, 3, you're going to reap rewards, $63,000, $70,000, $91,000. So if you wanted to do this mathematically, the way to do it would be to use this formula and draw it out. So 1.12 is 1 plus the interest rate here, or the required rate of return, which is 0.12. And that means that the company thinks it should be making a 12% gain. Okay? Okay, so they think they should be making a 12% gain. The t in this period is 0, right? So what does that do? If you just look at this part, 1.12 to the 0 power, what does that do? It's 1. Mathematically, that's 1. You could try it in Excel if you don't believe me, but 1.12 to the 0 power is 1. Whenever you take anything to the 0 power, it's always 1. Okay? So that means that negative 165 over 1 is going to be equal to negative 165,000. Okay? That's why you see that here. And you move on further, and it's pretty elementary stuff that we've done in the past. 63,120 over 1.12 to the first power. Then 70,800 over 1.12 to the second power. 91,080 over 1.12 to the third power. And you add all those up, you get 12,627.41. That's the NPV. That's the mathematical way to calculate. There is another approach, but first we need to teach the mathematical way because it's important for you to note that. It's pretty straightforward, right? These are all the required return formulas here. These formulas, we just went through each of these, and once you get those answers, you sum them up to get 12,627.41. Now in Excel, this is the same exact thing we just did here, so you can see it's summed up. So if you ever have any questions on what we've been doing in class, you can go to that Excel sheet and you can just click on the formula. You know, this is something good if you're not familiar with Excel, if you don't use it very often. This is very useful stuff because if you ever have a question on Excel, you can always just click on the formula, look at the formula where it's coming from. Okay? So clearly there's another method to get this answer, 12,627.41, 12,627.41. This method is an easier method, but there's a little bit of a caveat thrown in here that might trip you up. Okay? So let's real quick look at this formula here. If I enter in, which I can't because I've got a needle head. Let's close that little needle head. Bear with me for a second. See if this thing will work. Nope. Hold on just a moment. Sorry about that. Okay, so, and it's still there, so I'm not even going to type it in because I don't want to keep running into the same problem. If you look up here, you can see the formula. The formula is equals NPV, and then it goes D2. What is D2? D2 is the 12%. So the first thing you're going to put in is equals NPV, parentheses, D2, comma, and then you're going to scroll through here to show B5 through B7. So that means 56, 56, and 64. I'm sorry, B, 63, 70, and 91. It's better off that I do this. I need to figure out what to do. I'm going to open up a separate spreadsheet to show you this. I think that would be the easiest way to do it. Okay, so our numbers that we needed were these numbers, right? Post these here. Okay, so if you wanted to do this NPV formula, put NPV equals NPV, and then it asks you for your rate. I didn't copy that over, but I remember it was 12, right? It was 0.12. So 0.12, and then you're going to put in your values. Now, see what I did there? That's the tricky part. To rewind, I had to scroll down to get all of them. That's different than what we've done in the past, isn't it? In the past, we clicked on one cell and then we put the comma in. Now we're using what's called a range. Okay, so we're throwing them all in at once. And you scroll down and you hit enter. That gives us 177,627.41. We're not done yet, though. I just want to scroll back and show you that this is the same thing that they got there. Okay? We're not done yet, though. What do you think is the one other step that we need to do to get the NPV? Exactly. So all we used so far was the 63, the 70, and the 91. So we used those three elements. We did not use the initial outlay that we put out, which was $165,000. So they have to take that into account. Basically, what this is saying is, this is the money you're going to bring in from this decision. This is all benefit. What's the cost? And therefore, we have to throw that 165 in there. And the way to do that is just simply add the two. So I take this plus this, and you get 12,627.41. A key thing to note. This was the benefit, this was the cost. The cost is already in a negative form, so you should just add the two. If you ended up subtracting the two, what would have happened? It would have gone up substantially, right? And sometimes you'd make the wrong decision because you think things are positive that aren't supposed to be positive. So it's important to keep in mind that negative 165, if you have it written down as a negative, just think of it like it's an addition problem. But if you write it down as it's a positive, you can subtract it. So this 12,627 is greater than 0. Therefore, what's the point of this thing? You should do it, right? You should go ahead and make the decision to purchase that plan. All right, let's get back to that. Okay, so we went through that, and as you can see, there is a formula for the NPV, but it's a little bit more complicated. So this is just reiterating what we just went through. The NPV function was the NP equal to NPV, parentheses, rate, comma, and then you put in your cash flow 1 through cash flow, what they put here is NN, meaning until it stops. And in our example, it stopped in year 3, right? So it would go cash flow 1, and you'd scroll down to get the cash flow 3. Okay? This is definitely the important thing to note. I don't want you guys to get to the quiz next week and forget that. It's different than stuff that you've covered in the past, as far as using Excel. Okay, so it's something you should know. The first parameter, the required return, is entered in as a decimal, which is pretty straightforward. You've done that in the past. The second parameter, once again, is the range of cash flows beginning with year 1. Year 0 is when the outlay occurs. After computing the NPV, you then have to subtract that initial investment, which we've already done. You guys okay with this? All right. This is just, once again, yes, Jane?
On the slide 9, on the PowerPoint, it gives us net income. We didn't use that at all, and we're not going to?
No, I think that the reason they put that in there is just to try to get at, that's probably how they're developing the cash flows, but we're not getting into that right now.
Okay.
It's a good question, though. It's coming later. I believe we start to talk about how you actually develop those numbers. Right now, we're just kind of going, oh, we gave them to the other part of the finance department, and they came back and they said, you're going to make 12,000, no, it was like 63,000 in year 3. You're going to make whatever it was, 70,000. And do you know what I mean? Those three numbers were positive numbers. Right now, we're just assuming that there's another department giving us those numbers, and we're the guy who's like, okay, I got these numbers. How am I going to make a decision? You're going to use the NPV formula to do that. It's a good question, though, because those numbers come from something. We'll get into that a little bit. I don't think we get into it terribly too much tonight, but we'll get into it in this course. Right now, you're just assuming they're forecasted and somebody else is doing it. Okay, so this is our formula. We're used to this, and this is the one new thing that is important to note, particularly in Excel. Because in Excel, you have to subtract that out. You can use that NPV formula, but what's new about it is that you're not done after you use the NPV formula. It's confusing because you think when you use the NPV function, you're getting the NPV. And you're not. You have to do that one remaining step here. When you use the NPV function in Excel, only this blocked part is what you get. Then you have to do that subtraction of the initial 165 that we used as our example. All right. What's the rationale for this NPV method? The NPV is equal to your present value of inflows less your cost. So, an NPV of 0 is saying that project's inflows are exactly sufficient to repay the invested capital and provide the required rate of return. Exactly equal. Okay? Basically, the NPV greater than 0 is expected to create value for owners. This is important. The NPV greater than 0 is expected to create value for owners. So an NPV equal to the net is equal to the net gain in shareholder wealth. And of course our rule is to accept it if it's greater than 0. But why, another thing that's important here for the sake of our class, why is this method preferred? Why do we're going to show you some methods later that we don't prefer to use. If all else fails, we always use the NPV method. The question is, why is this method preferred over those other methods? The reason it's preferred is it considers all cash flows, it considers the time value of money, it adjusts for risk, and it can rank mutually exclusive projects. So in other words, we can sit here and we can go, okay, that thing's going to get us $12,000 if we did take the plant in Atlanta. But what happens if we did the one in Denver? What would we get then? So we could actually look at the net present value and say, well, that was $12,000, but the one in Denver is $15,000. So maybe we're going to do the one in Denver rather than the one in Atlanta. It's directly related to an increase in shareholder wealth, or the value of the firm. This is the value of the firm. And it's the dominant method that always prevails. In other words, we're going to show you some other ones once again. This is the one that we want to go with, the NPV method. Okay, so let's check out another, see how this video is going.